Hi and welcome everyone to one more lecture of probability and statistics. Today we will derive moment generating function for normal distribution. M.g.f for normal distribution. As we know, moment generating function is denoted by mxt and it equals to expectation of e raised to power tx. And as well we know normal distribution is a continuous probability distribution and its probability function is integration minus infinity to infinity 1 by under root 2 pi sigma e raised to power minus 1 by 2 sigma square into x minus mu whole square dx. Now our moment generating function will be e raised to power expectation of e raised to power tx equals to minus infinity to infinity e raised to power tx 1 by under root 2 pi sigma e raised to power minus 1 by 2 sigma square into x minus mu whole square dx. Now we know that z standard normal variate equals to x minus mu by sigma, and if we want to find out value of x in terms of z, so this will be equal to x equal to sigma z plus mu. Now if we will differentiate on both sides, we will get dx equals to sigma dz. That means dz is equal to dx by sigma. Now if we will replace value of x minus mu by sigma with z and x in the place of x we will put value sigma z plus mu. So this will be equal to integration minus infinity to infinity e raised to power sigma z plus mu times t dx by sigma will be dz into 1 by under root 2 pi e raised to power minus 1 by 2 x minus mu by sigma square will be equal to z square into z square. Now under root 2 pi is a constant, so we will keep this outside. So this will be equal to 1 by under root 2 pi integration minus infinity to infinity e raised to power sigma z t plus mu t into e raised to power minus z square divided by 2. Now sigma z t is this have a variable z, but mu t is a constant, so we can take mu t outside. So this will be, we can write this as e raised to power sigma z t into e raised to power mu t. We will take e mu t outside, so this will be equal to e mu t divided by under root 2 pi into integration minus infinity to infinity e raised to power sigma z t into e minus z square by 2 into dz. Now we can write this as e raised to power minus 1 by 2 into z square plus minus 2 sigma z t. Because we have 1 minus outside, we can write these as this. Now, if we want to make this a whole square, e raised to power minus 1 by 2 into z square minus 2 sigma z t. Now, if we will add and subtract sigma square t square, sigma square t square minus sigma square t square. Now, this is whole square of z minus sigma t. So, this will be equal to e mu t divided by under root 2 pi integration minus infinity to infinity. Now, we can write this as e raised to power minus 1 by 2 z. This is a whole square of z minus sigma t square minus 1 by 2 times sigma square minus sigma square t square. So this will be into e raised to power sigma square t square by 2 into dz. Now, this is a constant, so we can take this outside. So this will be equal to e mu t plus, because these two will be in multiplication, and if a raised to power x into a raised to power y equals to a raised to power x plus y. So using this property, this will be equal to e mu t plus sigma square t square by 2 divided by under root 2 pi integration minus infinity to infinity e raised to power minus 1 by 2 z minus sigma t whole square into dz. Now, if we will replace u with z minus sigma t, so du will be equal to dz. So this will be e mu t plus sigma square t square by under root 2 pi integration minus infinity to infinity e raised to power minus mu square by u square by 2 times du. Now, e raised to power minus mu square by 2. This function is an even function. Let's say we will put value of u equals to 1. So this will be e raised to power minus 1 by 2. And if we will put u equals to minus 1, so this will be e raised to power minus 1 by 2 again. Now, it doesn't get changed its value upon the sign. If they have same magnitude but opposite sign, its value is not changing. So it is an even function. And for an even function, integration minus a to a f of x dx for an even function equals to 2 times 0 to a f of x. This is a property for an even function's integration. So we can write this as, this expression will be 2 times e mu t, e u t, wait a second, this is mu t plus sigma square t square by 2 divided by under root 2 pi integration 0 to infinity. Initially it was minus infinity to infinity. Now we will make this interval half and we will multiply this with 2 e raised to power minus u square by 2 into d. Now this is our expression. Now if we will put u square by 2 equal to v, so differentiation of this will be 2 mu 2u into du divided by 2 equals to dv. Now 2 divided by 2, so dv equals to du by u and v equals to mu square by 2. Now if we will replace the value, so this will be 2 times e raised to power mu t plus sigma square t square divided by 2 divided by under root 2 pi integration 0 to minus infinity 0 to plus infinity e raised to power minus mu square by 2 will be e raised to power minus v and du will be dv times u, dv into u. Now as we know v equals to mu square by 2, so u will be under root 2 v into root 2 v, root 2 v. Now we can write this as 2 e raised to power mu t plus sigma square t square by 2 divided by root 2 pi integration 0 to infinity by root 2v. Now v raised to power minus 1 by 2, we can write this as under root 2 e raised to power minus v dv. Now root 2 got divided by 2, so this will be cancelled out, this will be cancelled out and this will be cancelled out. Now as we know t of alpha, that is gamma function of alpha, equals to integration 0 to infinity alpha x raised to power alpha minus 1 into e raised to power minus x dx. This is gamma function of alpha, x raised to power alpha minus 1 e raised to power minus x dx. And if we can see here, this is 0 to infinity minus 1 by 2 v raised to power and e raised to power minus v dv. Now if we will replace v by x, and so our alpha will be alpha minus 1 equals to minus 1 by 2, so alpha will be 1 by 2. So this whole is gamma function of 1 by 2. So this will be equal to gamma function of 1 by 2 into e raised to power mu t plus sigma square t square by 2 divided by under root pi, because this 2 will be cancel out. Now we know that gamma function of 1 by 2 equals to under root pi. Now under root pi and under root pi will be cancelled out, and our expectation of ETX, that means moment generating function, will be equal to e raised to power mu t plus sigma square t square by 2. So this is our moment generating function. That's all. We will meet in our next lecture. Thank you.